Okay, so we're going to talk about theoretical and experimental probability. So they're important ideas that have been used before, and sometimes they're a bit confused. So I just want to talk about some terminology first. So the first one is outcome, and that just means what possible results there are from the data we're looking at. Event is when an outcome happens, and probability is a number between 0 or 1 that represents the chance of something happening. Now, probability can be written as a percentage, a fraction, or even a decimal. And all of those are perfectly valid ways to write probability. And if you have a look down here, you can see that this is the way that the terminology is used. So what this says, for all events, the probability of that event happening is between 0 and 1. 0 is 0 chance, 1 is certain chance, and the others are spread out over that range. Okay, so there's a formula here in the middle, which is what we use for theoretical probability. The probability of an event happening is the number of outcomes when that event happens over the total number of possible outcomes. As I said, it can be written as a decimal, fraction, or percentage, and sample space is a term that simply lists all possible outcomes for an event. And there's an example: when rolling a die, the sample space is 1, 2, 3, 4, 5, 6, because they're your possible outcomes. Okay. Now, some other terms: complement of an outcome. So what that is the opposite of the outcome actually occurring. So if you write it as O for outcome, then complement is written as O dash. See that little dash next to it? And the value of this is together, all they add to 1. So if we think about that, the probability of rolling a 1 on a dice and the probability of not rolling a 1 on the dice are all possible outcomes for that event. So together, their probabilities equal 1. And what's really useful about this is we can rearrange that formula to this and often save ourselves quite a bit of work in finding something. So the probability of not getting an A equals 1 minus the probability of getting that A. I'll show you an example of one as well. So here's some examples. So the probability of rolling a 2 on a die is that how many 2s there are over the total number. So there's 1 2 on a die and 6 possible outcomes, 1 over 6. The probability of not rolling a 2 on a die is all of the outcomes that are not 2 over that, or even better, you would write 1 minus 1 over 6 as working that you would put there. So together, they obviously equal 1. So all possible outcomes. Okay, let's have a go at this. So list a sample space using those given numbers. So let's do all of these together now. So 1, sample space. Now, sample space is written in curly brackets. So all you're doing when you're writing the sample space is listing the possible outcomes. In this case, there's 7. Something to note for sample space. So note, sample space does not include multiples. And what that means is if you have multiples in your possible outcomes, for example, if we had one that said 1, 2, 2, 4, then our sample space here would only be 1, 2, and 4. The fact that there's 2 2s doesn't change what the possible outcomes are. It simply changes the chance of getting that possible outcome. So keep that in mind, that sample space doesn't matter how many times it occurs, it's just a list of the possible outcomes. Okay, 2. Find the probability of 2. So the probability of 2. Now you should write a formula in words each time. So what we're looking for here is the number of 2s over the total outcomes, the number of total outcomes. So in this case, there's 1 2 in our spinner and there's 7 total outcomes. So 1 over 7 is our probability of getting a 2. The probability of not a 2 though we can use that complement rule. So that's going to be 1 minus the probability of getting a 2, because we want all of the possible outcomes that are not 2s, and we already know what the probability is to get a 2, so use that where you can. So that's going to be 6/7. Find the probability of a 2 or a 3. So in this case, you want the number of 2s and 3s over the total outcomes. And there's 2 of them, and there's still 7 in our sample space. And the last one, find the probability of a number which is at least a 2. So we want at least a 2. So that's going to mean we want the number that is 2 or greater. So 2, 3, 4, 5, 6, 7 over total outcomes. Again, you could use the complement here of numbers less than 2, so the probability of getting a 1. Or because it's simple, we could go straight to using this. Okay, hope that helps.